Hi, this is Electronics. In this video I will present you how to or how not to make a homemade boombox. I made this homemade boombox back in 2016. This was one of the first projects on which I learned how to use the TDA 2003 IC and to make variable active low-pass filter circuits. Through the years I made some improvements and changes on it, which will be presented later in this video. This footage was made in 2016. As you see, the front panel was different than what it has now. It had 3 speakers. On the top there was the big 6.5-inch speaker for low, a 2-inch 1-watt speaker for mid sounds and a tweeter for high frequency sounds. The bass reflex port was made without calculations, so it wasn't working as intended. Later I changed it to tube, which was a better option. This boombox has 2 amplifier circuits inside, both are based on TDA 2003 audio amplifier IC. One is for the low range and one for the mid and high range. This option was not the best choice because the power supply transformer couldn't handle 2 circuits. Now you can see the current version of the boombox with the bass reflex tube. I start to take it apart. 4 Phillips head screws are holding the backplate. I will speed up the video while I take it apart. As you can see, I've used sponge on the backplate as a damping material in the speaker box. This will be changed later in the video. In this video I will make further improvements to the boombox, but before I start to make the modifications, I just give some more information about what's inside the box. I use a 12V 1.2A transformer and the diode bridge is inside the boombox. After rectification and 3300 microfarad decoupling capacitor, the voltage rises to 18.6 volts. A 7815 voltage regulator IC is located on the circuit board and it is used to make stable 15 volt supply voltage. Here is the schematic I made back in 2016. TDA 2003 audio amplifier IC is used in this project. I put a link in the description for the datasheet. The output power with 15 volt supply voltage is around 6 watts. Here is a close-up shot of the amplifier circuit with the voltage regulator and the new heatsink. The incoming stereo signal is united to mono signal using a pair of 51 ohm resistors. Now I will show you the changes I made on the boombox. First, I removed the second amplifier circuit because the power supply couldn't handle 2 amplifier circuits. When I was listening to music loudly, it started to distort very early. Also, the second amplifier didn't give the necessary increase in loudness, just made the circuit more complicated and unreliable. Second, I have removed the active low-pass filter elements from the first circuit. This circuit was an amplifier with adjustable active low-pass filter, but it didn't work as good as I expected, so I removed these elements, making the circuit full range again. The filter consisted of resistors, capacitors and a trimmer to adjust the filter's attenuation. I will show you how to make an adjustable active low-pass filter circuit in another video. Here you can see that these elements are already desoldered from the circuit. Third, creating a passive high-pass and low-pass filter for the corresponding speakers, which will be a 2-way speaker crossover. For the mid-high frequency speaker, I connect a Philips 10 microfarad capacitor in series, which will only pass the mid-high frequencies to the small speaker. Here you can see it working with the oscilloscope, showing how it cuts off low frequency sounds. For the low frequency speaker I make an LC low pass filter consisting of a coil in series and a capacitor in parallel. This coil was salvaged from Philips crossover circuit and the capacitor is just a normal 100 microfarad electrolytic capacitor. I will show you again how it looks when it filters out the high frequency sounds with the help of my oscilloscope. Fourth, verifying the low frequency response of the circuit. With the help of my 3.9 ohm power resistor and the oscilloscope, I could measure that the lowest frequency response is around 80 Hz, and it is more than enough for this boombox. Fifth, removing the old ugly sponge from the backplate and also from the box frame. I have used sponge for sealing the gaps between the walls, which was a bad decision, so I removed those. Lastly, I use sandpaper to remove the leftover glue. Sixth, filling the holes and gaps with cardboard, glue and silicone. This box is handmade and it has gaps between the walls, also some connectors might have small holes, so these must be solved. Seventh, inserting polyfill material. This material was saved from an old Philips speaker and it will help to reach lower frequencies. Eighth, covering the box with black self-adhesive wood pattern vinyl wrap. This will make the boombox look way better than the original wood. First step is to remove almost everything from the box and clean it from dirt and dust using a piece of cloth and alcohol. After that I start to apply the vinyl wrap. It requires a cutter, a scissor and a lot of patience to do it. This process can take up easily an hour, so I speed up the video. When the vinyl wrapping is finished, the next step is to cut the holes.
Next level.
Here is the final result, which I think looks way better than the original. 9th, connecting a small Bluetooth receiver module so the boombox will have Bluetooth connection. For this purpose I will use the XYBT mini Bluetooth receiver module and the 7805 voltage regulator. Recently I made a review video about the Bluetooth receiver module, you can check it out here or on the link in the description. I do not recommend using 78L05 small voltage regulator because it can't regulate high voltage difference and burns out easily. Instead use 7805 and a small heatsink. I've connected the 7805 voltage regulator to the 18.6 volt supply with a 100 ohm resistor as a current limiter. Also a 2200 microfarad capacitor is soldered to the power supply pads of the receiver module. The reason for this is that the receiver module picked up some noise or probably ground loop problem. This capacitor resolved the issue. Here you can listen to the noise it made. I have successfully connected the Bluetooth receiver module power lines and made a test with success. After that I've soldered two pieces of 4.7 microfarad 63 volt audio capacitors to the output pads of the receiver board and three wires for the stereo channel and the ground. The wiring was finished and the Bluetooth receiver worked well. 10th, filling the gap between the box and the backplate with window sealing tape. I use this rubber window sealing tape to seal the box better. The homemade boombox is finished. I just put the polyfill inside and tied the screws back to their place.
Next level.
Thank you for your attention. Leave a like if you want to see more videos like this and don't forget to subscribe.